This is the review for the first part of y'all's test. So on number 1, the fraction, the exponent is negative, so that means you have to flip it. So I'm going to leave that negative out front and flip the 16. Now remember, that means 16 cubed square rooted because it's power over root. Okay, so you can do either part first, but it's easier if you do the root part first. So the square root of 16 is 4, and then when I cube it, I get 64. So negative 1 over 64. Okay. Now number 2, raising it to the third power, all we have to do is raise powers to powers, so that means multiply. So you're going to do 3 times 1/2 and get 3 halves. You're going to do 3 times this imaginary 1 here and get 3, and then also on the bottom, so we get y 3 halves. Okay, and then we have to simplify it so that there's only one of each letter. So like we only have one x, so that's good. That'll be part of our answer, but we need to simplify the y's. So common denominator, 3 over 1, we're dividing, so we subtract. Oh, so the common denominator is 2, and so I get 6 over 2 minus 3 over 2 is 3 over 2. So we get y to the 3 halves as well. Okay, so that was that answer, and this was the answer to this one. Okay, number 3, we're doing it to the 5th root. So we have to first think about the number. So there is no 5th root of 64, but we have to think about a number that'll go into 64 that there might be a 5th root of. So 5th roots aren't something you're gonna have memorized. So just come over here to the side and think, okay, what's 2 to the 5th? Because 1 to the 5th wouldn't help us. 2 to the 5th is 32, and check and see, does 32 go into 64? It does, 2 times, so that's the number we needed. But if it hadn't been, just go to 3 and keep going like that. Okay, so the 5th root of 32 is 2, so we're gonna have this 2 come out front. I'm gonna leave a little gap so I can fit my letters, and then this 2 will stay under. Okay, now if they divide evenly, then that's great. 10 divided by 5 is 2, so that means 2 comes out and there's none left. But here, 8 divided by 5 doesn't work evenly. So it'll go in there once, but then I have 3 left. So 1 comes out because it went in there once, and then I have 3 left. So the 3 stays under. Okay, so that would be my answer there. Now number 4 would normally be an easy calculator problem, but your calculator isn't going to do these, so we have to break them down. So 9 and 2, 25 and 2, 9 and 3, 25 and 3. Okay, so the square root of 9 is 3, so we have 3 square roots of 2 minus 5 square roots of 2 plus 3 square roots of 3 minus 5 square roots of 3. So now combine like terms, we have these 2, and then we have these 2 that are like terms because they have the same number under the root. So 3 minus 5 is negative 2. 3 minus 5 is negative 2. And then that would be our final answer because they're not the same root, so we can't do anything else to them. Okay. On number 5, remember anything squared means write it twice. So distribute, we get square root of 25 plus square root of 15 plus square root of 15 plus square root of 9. So this is 5 and this is 3. And then we have 2 square roots of 15 because we have 1 here and 1 here. So combine my 5 and my 3, I get 8. Oh, I kind of messed that up. 8 plus 2 square roots of 15. Okay, number 6, I cannot have a square root on the denominator, so multiply by the conjugate. So square root of 5 minus square root of 3. top and bottom. Okay, and then distribute. So on top I get square root of 10 minus square root of 6. On bottom I get square root of 25 minus square root of 15 plus square root of 15 minus square root of 9. So the middle terms always cancel on conjugates. And then I have 5 minus 3 on bottom, which is 2. On top, neither of those break down. And remember, you cannot divide by 2 because those are square roots. So that is just your final answer. So once you get it where there's not a square root on the denominator, you're good. And check to make sure you can't reduce. Okay, number 7. This was the harder one that we worked when I came in person. But I'm going to work it again. So remember, division means keep, change, flip. So let's start with the first one. And I remember some of you were doing it a different way, and that's fine. I'm going to do it the box way, but if I need to do it another way, let me know. So first and last, 2 times negative 3 is negative 6. So I need factors of negative 6 to give me negative 5. And remember, the signs need to be different. The biggest one, so the signs need to be different. So we don't want to do 2 and 3, because 2 plus 3 would work, but we want to do negative 6 and positive 1 because we need different signs. So we need them to subtract. Okay, so here we could take out a 2x, here a 1, here an x, here a negative 3. Okay, so we have 2x plus 1 times x minus 3. Okay, now coming down here with this one. We have 5x squared and a minus 1 at the end. So we need factors of negative 5 that give us negative 4, so negative 5 and 1. So here I can take out a 5x. Here I can take out a 1, here an x, here a negative 1. Okay, now remember we're doing keep, change, flip. So I'm gonna go ahead and do the bottom on top real quick. So this would be, this one you can just normal factor. So factors of 3 that subtract to be 2 would be 3 and 1. The signs are different. The biggest one is positive. And remember that moves to the top. Okay, and then that last one there. Oh, I made that really small. Let's see if I can squeeze that in there. 2x2, positive 3. Okay, so I need factors of positive 6 that give me positive 7, which would be 6 and 1. So here I get 2x, here 1, x, and positive 3. So I've got 2x plus 1 and x plus 3. Now remember, if pretty much everything doesn't cancel, then you did something wrong. So 2x plus 1, x plus 3, x minus 1. Okay, so we're left with one thing on top, x minus 3, and one thing on bottom, 5x plus 1. And so that would be our answer for that one. Okay, number 8, we have to factor. So first we have sum of cubes. So remember, cube root it, leave it just as it is, the signs, then square the first, multiply together and change the sign, square the last. Okay, on bottom, I see I could take out a 3, but then when I do that, this is difference of squares because I can square root both of them. So that would become x plus 1 and x minus 1. And then anytime there's an x squared, you want to check and make sure you can't factor it further. So if you look here, factors of 1 that add to be negative 1, that doesn't exist. So we don't have to worry about that. Up here, we can take out a 6. And we don't have an exponent, so there's nothing else we can do there. And then down here, I see I can take out a GCF of an x. And then factors of 1 that add to be 1. Again, there's not that, so we're good here. But anytime there's an exponent higher than 1, you need to check and see if you can factor further. Okay, and same thing here. Pretty much everything should cancel. So the x plus 1's cancel. This big thing cancels. X minus 1 cancels. And even our 3 and our 6 will reduce. So 3 goes into itself once and into 6 twice. So we're only left with a 2 on top and an x on bottom. So that would be all. Okay, on number 9, we're adding fractions. You have to have a common denominator, which this one does have already, so that was easy. Keep that, and then combine like terms on top. So 5 minus 7 is -2, -3 and 5 is +2. Okay, but let's look and make sure there's not a GCF anywhere, and I see that there is one on top. And I'm gonna take out a -2 because it's in the front. And look what happens. The x minus 1s will now cancel. If you don't notice that on a test, I would probably only take off like 1 point, but still just try to factor, try to do GCF, try to do anything you can every time. So GCF is the only thing you can do if there's not an exponent, like here, okay? Number 10 is domain. So remember, domain means I don't care about the top, I only care about the bottom. And I want to know what it cannot equal, which is 0. So what would make this denominator equal 0 is -5. So x cannot be -5. So you can write it like this. This symbol means all real numbers except x cannot equal -5. Or you can do it in interval notation and say that it's all the numbers from -infinity to -5, not including, and then picking back up and going to infinity. So either way, you don't have to write both, but either of those would work. Okay, number 11, when you have a complex fraction, you want to get rid of it, so get a common denominator. Okay, which would be x plus 4. And you're going to multiply each piece by that to get rid of one set of the fractions. Okay, so this would just be, you just distribute, so you get x squared plus 4x. And then here, that's going to cancel. So I just get plus 4. So that's my whole top. Then on bottom, I distribute here, so x squared plus 4x. And then here, cancels again, but this is where you have to be careful, is if you have a minus. So you remember, you have to go change, 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 and change everything after it. So we really have minus 4x and minus 4. So that means these cancel. So on top, let's think about it. Are there factors of 4 that add to be 4? There are. 2 and 2. Signs are the same, they're both positive. On bottom, I have x squared minus 4, which I can square root both of those. It's the difference of squares. So remember, one's a plus and one's a minus. So one set of those will cancel, and I'm left with x plus 2 over x minus 2. Again, a complex fraction problem usually simplifies pretty good where there's not a lot left, okay? Number 12, it's a complex fraction problem, but you have to make it into one. So these are added, so they're gonna stay in separate fractions. So you can't put them together. But these are multiplied, so the b is positive, so it stays on top, and the a goes to the bottom. So that's the difference. The top has a plus, that's why they're separate. They're still added together, but they're not combined. Okay, so think about your common denominator. We need a2 and b2. So everywhere will be an a2, b2. Okay, so here the a2s will cancel. b2 times 1 is just b2. Here the b2s will cancel. a2 times 1 is a2. Here the a's are going to reduce, and we only have 1 because 2 minus 1 is 1. And then these b's are gonna add since they're both on top, and we get b3. Okay, and there's not a common denominator on top. There's not a sum of squares because that doesn't exist. And so there's nothing we can reduce. That's just it. A few more for the first half. Okay, number 13, we're just distributing. So we get 10 minus 2i squared of 7 minus 15i squared of 7 plus, okay, 3i squared. Oh, I'm running out of room. And then square root of 7 times square root of 7 is square root of 49. Okay, so let's combine these or like terms. They both have an I and a square root of 7. So negative 17i square root of 7. And then here, okay, well, this is the one we have to watch. So plus 3, I squared is negative 1, and then square root of 49 is 7. So that's all multiplied together. So that gives us negative 21, which is now like terms with a 10. So I get negative 11 minus 17i square roots of 7. So just take it slow, show your work, and you should be okay. Okay, number 14, we're just simplifying. So let's break down this square root to, okay, so you might look at that and do 8 and 4, but remember 4 can also go into 8. So it'd be simpler if you do 16 and 2, and then you only have to do it once. If you do it the other way, you're gonna have to break it down twice. So the 4 would come out. Remember, a negative square root is an I, and the 2 would stay under. Okay, and since all 3 of my outside numbers that are not in the square root will reduce, we need to divide everything by 2. So we get negative 2 plus 2i square root of 2. So don't mess with this one because it's stuck in the square root. Okay, and then this is super easy, do not miss it. But it's not distributing, it's subtraction. So remember, change, change, change. Now I have 6 and negative 3, just 3. I have negative 7 and negative 4, which is negative 11. So that's probably the easiest question on the test, but just, it's last, you've been doing a lot of hard ones, and so you might overthink that, so don't do that. And if it's the same, just whatever it's doing, make sure you pay attention to. If it's like this, you distribute, like touching, but if there's a sign in the middle, make sure you do the sign. Let me know if you have any questions.